This is part 2 of Unit 3, Lesson 1 on the chain rule. We are continuing with example 3, which are different ways that the chain rule exists. So starting with letter G, we have f of x equals the natural log of x squared plus x plus 1 squared. Now what we have here is we have a double chain rule situation because we have an outside function of the natural log. Then we have a second function of a base raised to the second power, and then our third function, which is that quadratic polynomial. So we are going to have to use the chain rule twice. So f of x becomes, as a derivative, f prime of x is going to, first we're going to take the derivative of natural log. So that's going to be 1 over x squared plus x plus 1, and then we're going to do the power rule on that, so that will be times 2 times x squared plus x plus 1, and then we have to take the derivative of the quadratic polynomial, which will be 2x plus 1. So here is part 1. Here is part 2, and then here is the third step. Okay, so simplifying, so the 1 power is going, oh, I forgot to raise that to the second power, I apologize. So this will be to the second power because I'm going to take ln of this whole thing. So then one of these is going to cancel out with that, so I'm going to be left with f prime of x is going to be 2 times the 2x plus 1, and that's going to be over x squared plus x plus 1, because the power of 2 will cancel with this power right here. And then this, you can leave it like that, or you can write it as 4x plus 2 over x squared plus x plus 1. Okay, now next we have not only are we going to have the chain rule, but we also have the product rule to start with. But this can be simplified. So sometimes this looks like a little bit of a beast to do, but if you simplify it, it becomes easier. So what we have here is we can simplify it in this way. We can look at, I really don't want an equal sign there. We can look at our e to the negative 4 ln of x like this. We can put that power back up. So we're taking e ln of x to the negative 4. So that is going to simplify. These are inverse operations. That'll simplify to x to the negative 4. So our function then becomes x squared times x to the negative 4, which is really x to the negative 2. Now I'd much rather take the derivative of that than that product rule chain rule. So then our derivative becomes negative 2 times x to the negative 3, which is negative 2 over x to the third. That would have been a lot more difficult to simplify and do had we used the chain rule. So always think about that before you do it. Okay, next one, letter I. Now we have two trig functions that are squared, and then we also have the 4x, which is a third function. So we have 3 functions here. We have the squaring of a function, then we have the trig function, and then we have the linear function, the 4x. So this is going to be then g prime of x. So the first thing you want to do is bring your power down, which is a 2, lower the power by 1, cosine of 4x. And then you're going to take the derivative of cosine, which is going to be negative sine 4x. And then that has a derivative inside of it, which is the derivative of 4x, which is going to be 4. Okay? And we're going to do the same thing with the second part. So we're going to minus, we're going to bring the 2 down, lower the power of sine by 1, then take the derivative of sine, which is cosine. So we have cosine 4x. Then we're going to take the derivative of the 4x again, which is 4. So this simplifies to, we have negative 8 cosine 4x sine 4x for the first term, and the other term becomes negative 8 sine 4x cosine 4x, which are the same term, so I can combine those. So you get negative 16 cosine 4x sine 4x. So that'll be our derivative. Okay, so I'm going to leave letter J for you to do, and letter K, and letter I. Then I'm going to do the last two. So let me stop here since they're together, those three, and you can do those and check your answers. So make sure you pause the video. Okay, so there's J, K, and L. And as always, if you did not get those solutions, please ask in class tomorrow. All right, continuing on. So we have M and N to do. So let's do those. So for letter M, we're going to take the derivative of g of theta. So g prime of theta is going to be 4. Then we're going to lower the power by 1. So we're going to bring the power down, lower the power by 1. Take the derivative of the cosine, and then take the derivative of pi theta, which is pi. So our derivative is going to be negative 8 pi cosine pi theta sine pi theta. Okay, and then for the last one, tangent, I'm just going to rewrite it this way, that y equals tangent of 2x minus 3 to the 1/2 power. Now notice it's not the tangent to the 1/2 power, it's the argument of tangent. So the derivative is going to be, y prime is going to be, so we're going to take the derivative of tangent, which is secant squared, the square root of 2x minus 3. And now we have to take the derivative of square root of 2x minus 3. So we have a power, so we're going to bring that 1/2 down, lower the power by 1, so then we're going to have 2x minus 3 to the negative 1/2, and then take the derivative of 2x minus 3, which is 2. So the half and the 2 is going to cancel, so we're going to be left with y prime is going to equal secant squared, the square root of 2x minus 3, and then we have this square root of 2x minus 3 that needs a positive exponent. Okay, and then finishing up this lesson is we are always going to go back to tables because the AP test loves tables. Okay, so let f of x be continuous and differentiable function on the intervals 0 to 1, including the endpoints, and let g of x be f of 4x. So the table below gives values of f prime of x, the derivative of f of x. So we're supposed to find the value of g prime of 2. So here's where you're going to need to work through how the chain rule works. So here's what we know. We know that g of x is equal to f of 4x. So we need to find the derivative of g of x. So g prime of x is going to be, here's where the chain rule comes in, the derivative of f prime of 4x. And then we have a derivative inside 4x, so we have that. So the derivative of 4x is going to be 4, so we get 4 f prime of 4x. Okay, so we want g prime of 0.2. So what we have to know is that we're going to take 4 times f prime of 4 times 0.2. That's why we needed that derivative. So we're looking for 4 times f prime of 0.8. And so now we go to the table and we see at 0.8 we have the value of 1.125, or 1 1/8. So this is going to be 4 times, and I'm going to write it that way, 1 1/8. Or, you know what, I'm going to write that as 9/8. It's going to be easier to simplify. Simplifying that, we get 9 over 2, which is 4.5. So that's the answer, 4.5. Okay, next table example. So we're going to use this table to answer the following questions. So what we have is we have a function that's defined in the table for x's -1, 0, and 2, and then we have the values of the function f, its derivative f prime of x, and then we have a second function g that's defined for those values, and its derivative g prime of x. So we're supposed to find the equation of the tangent line at x equals 1 if h of x equals 3 times f of g of x. Okay, so what we need to do first is find the y value. So we're going to find h of -1, which is going to equal 3 times f of g of -1. So that's going to be 3 times f of, and we go to the table, g of -1 is -1. So we're going to find 3 times f of -1. So 3 times f of -1 is -2. So this is, whoops, this is going to be 3 times -2. So we get -6. So we're going to need that for our equation of our tangent line. So we have to find h prime of x. So h prime of x is going to be 3 times f prime of g of x. This is just our definition of the chain rule times g prime of x. Okay, so we want to evaluate this when x is -1. So we're going to have 3 times f prime of g of 1 times g prime of 1. So we're going to get 3 times f prime g of 1. Did I put the wrong number in? I did. It's -1, so I forgot to put -1s in there. There we go. So we want g of -1, which is -1, and then we're going to multiply that times g prime of -1, which is 2. So this is going to give us 3 times f prime of -1 is 4. 3 times 4 times 2, which is 24. So there's our slope. There's our m right there. Okay, so our equation of our tangent line is going to be y is going to equal 24 times x plus 1 minus 6. All right, that's part A. Part B then says, if j of x is f of g of x times cosine of x, what is the value of j prime of 0? So the first thing we have to do is find j prime of x. So j prime of x is going to be, okay, so I first took the derivative of cosine, which is negative sine x, times f of g of x, and then plus, I'm going to keep the cosine, and then take the derivative of f of g of x, and that's just our chain rule. So we're going to have f prime of g of x times g prime of x. Okay, substituting everything in we need, so we're going to do j prime of 0. So we're going to do negative sine of 0 times f of g of 0 plus cosine of 0 times f prime of g of 0 times g prime of 0. Well, the first term I can just forget about because sine of 0 is 0. So the second term is going to give me 1 times f prime of g of 0. So g of 0 is in our table, so we need g of 0 and g prime of 0. So g of 0 is 2, and g prime of 0 is negative 3. So we're going to do f prime of 2 times negative 3, and then we just need f prime of 2. So f prime of 2 is going to be negative 2. So we'll fill that in, and we're pretty much done. So this is going to equal, we don't even need the 1 anymore. So negative 2 times negative, why is this not writing? Because I'm on the eraser. Negative 2 times negative 3, so we get 6. Okay, so that is our lesson on the chain rule. We will be going over this in class if you have any questions, and I will see you on the next video.